The Intergalactic Science Academy had watched over the known universe for 12,000 years. Its towers of living crystal rose from the surface of Nexus Prime, catching the light of 3 suns and scattering it across the academic grounds like scattered jewels. Within those towers, the greatest minds from 800 different species studied the laws that governed reality itself. They measured, they calculated, they proved. And above all else, they protected the sacred truths of physics from doubt and question. High Academician had served the Academy for 300 years. As a being of pure geometric thought, existing as a complex shape that folded through 11 dimensions, understood physics in ways that biological creatures could not even imagine. The High Academician had witnessed the discovery of 17 new fundamental particles, the mapping of dark energy currents between galaxies, and the final proof of the unified field theorem that had taken 6,000 years to complete. Nothing surprised anymore. Nothing seemed capable of doing so. Then the humans arrived. They had only discovered faster-than-light travel 3 of their generations ago. By galactic standards, this made them infants, bobbies crawling across the stars. Their little ships were crude and loud, their mathematics was messy and incomplete, and they had somehow managed to nearly destroy their own planet before even reaching space. Every senior academician agreed that humanity would need at least 1,000 years of careful instruction before they could contribute anything meaningful to galactic science. The Integration Committee met in the Grand Hall to evaluate humanity's application for scientific exchange. Presided over the meeting, surrounded by the finest minds the Academy had to offer, there was Professor Aura, whose ancestor had established the absolute upper limit of energy conversion efficiency. There was Master, a cloud of sentient gas who had spent 2 centuries studying the behavior of matter at quantum scales. And there were dozens of others, all waiting to hear what the young species had to offer. The human ambassador was a small creature called Doctor. She stood barely 2 meters tall, wrapped in soft biological tissue, powered by chemical reactions inside her body. By every objective measure, she should have felt intimidated standing before beings who had mastered the cosmos. Instead, she smiled with what seemed like genuine excitement. "Thank you for having us," she said through her translation device. "We brought a few demonstrations." Master rippled with amusement. "How charming! Please show us what you have learned." Doctor nodded to her assistant, a young man named who carried a metal case. He opened it and removed a device about the size of his forearm. It was made of cheap alloys and wrapped in what appeared to be adhesive tape. Several academicians made sounds of polite disgust. "This is a quantum tunneling macro-inducer," Doctor explained. "We built it to solve a mining problem back home. Some of our minerals are trapped behind really hard rock, and drilling was expensive." She placed a solid iron sphere on a table in the center of the hall. Then she ordered the assistants to wheel out a thick slab of condensed. This material was among the densest substances in the universe. Nothing could pass through it. The mathematics had been proven thousands of years ago. It was literally impossible for macro-scale objects to tunnel through. Doctor pointed her device at the iron sphere and pressed a button. The sphere shimmered, blurred, and then appeared on the other side of the barrier. It had not gone around the barrier. It had not broken through it. It had simply passed through it, like a ghost walking through a wall. The Grand Hall went completely silent. Felt several of their dimensional folds twist in confusion. "That is not possible," the High Academician said carefully. "The theorem of scalar limitation clearly states that quantum tunneling effects cannot manifest at the macro scale. The mathematics have been proven for 6,000 years." Doctor looked genuinely puzzled by this reaction. "Oh, right, we read about that theorem. Very elegant work, but we found a workaround." "A workaround?" repeated. "Yeah, if you pulse the quantum field at the right frequency, you can extend the tunneling window long enough for larger objects." She shrugged. "It took our team about 3 years to figure out. We thought it was pretty well known." "It was not well known. It was not known at all. It was supposed to be impossible. Master demanded to examine the device. The humans handed it over without hesitation. The cloud of sentient gas spent several minutes probing its inner workings, then made a sound that the translation devices could only render as distressed buzzing. "This should not function," announced. "The principles it employs contradict established physics." The assistant looked uncomfortable for the first time. "Should we not have brought that one? We have others." The second violation occurred during lunch. The Academy prided itself on hospitality. A banquet had been prepared featuring delicacies from across the galaxy. The humans sat at a table with several junior professors who had been assigned to make them feel welcome. The conversation had been polite and meaningless until mentioned something about his work. "I'm an engineer," he explained between bites of synthesized protein. "Mostly I work on drive efficiency. We just upgraded our fleet to exceed the constant by about 40%. Professor Ara, who had been passing by the table, stopped walking. Her crystalline body produced a sharp ringing sound. "Repeat what you said." "Looked nervous. We exceeded the constant by 40%. "That is the absolute upper limit of energy conversion efficiency," Ara said slowly, as if speaking to a child. "My ancestor proved this 4,000 cycles ago. It cannot be exceeded. The mathematics are absolute." O pulled a paper napkin from the table and produced a small writing tool from his pocket. "Right, we read that paper too. Really impressive stuff for its time. But here, look, if you use basic thermodynamic cycling with a feedback loop." He began sketching equations on the napkin. The mathematics was crude. The notation was barely readable, and the conclusions were completely, utterly, undeniably correct. Professor Ara stared at the napkin for a long moment. Then she made a high-pitched sound and had to be carried away by medical staff. Two other professors who had been watching followed shortly after. By the end of the first day, the humans had casually broken 6 fundamental laws of physics. They demonstrated a communication device that sent messages faster than light without using subspace relays. They showed a material that remained solid at temperatures where atoms themselves should have melted into plasma. They produced a mathematical proof that suggested dark energy could be harvested for practical use, something the Academy had declared impossible just a century ago. And through it all, the humans seemed genuinely puzzled by the reactions they received. "We're not trying to be difficult," Doctor said during the evening session. She sat across from in the High Academician's private chambers, surrounded by floating displays of everything the humans had demonstrated. "We thought we were sharing basic technology. We didn't realize it would cause problems." "You have violated fundamental laws," said. "Laws that have stood for thousands of years. Laws that define the very nature of reality." Doctor tilted her head. It was a strange gesture, but the High Academician had learned it indicated thought. "With respect, High Academician, I'm not sure those are really laws. They are proven mathematics." "They're models," she said gently. "Really good models made by really smart people. But they're still just descriptions of how the universe seemed to work based on the observations available at the time. The universe itself doesn't care about our models. It just does what it does. And sometimes, if you push hard enough and get creative enough, you find out the model was incomplete." Stared at the small human for a long time. In 300 years, no one had ever spoken about physics this way. It was almost heresy. It was definitely dangerous. And yet, the iron sphere had passed through the barrier. The drives exceeded the constant. The impossible kept happening, over and over, as if reality itself was taking the human side in this argument. Convened an emergency session of the full Academy Council that night. The message was simple. Humanity had either found ways to cheat reality itself, or everything the institution had built over 12,000 years was terribly, catastrophically incomplete. Neither option was acceptable. Both had to be investigated. The universe, it seemed, still had secrets, and the young species with the crude ships and messy mathematics had somehow learned to find them. The Academy dispatched its finest theoretical minds to Earth within a week of the emergency session. Professor Aura led the expedition, having recovered from her initial shock, and replaced it with something between scientific curiosity and personal offense. Her ancestor had established the constant. Her family had built their reputation on that law for 4,000 years. If humans had truly found a way around it, she needed to understand how. The journey to Earth took 3 days through standard transit lanes. The human home system was small and unremarkable, a single yellow star with a handful of rocky planets and gas giants. Earth itself was a blue and green sphere, mostly covered in water, with a surprisingly thin atmosphere. Ara found it hard to believe that such a fragile world had produced a species capable of rewriting physics. The first human institution they visited was called MIT. The translation devices explained that this stood for Massachusetts Institute of Technology, one of the most prestigious centers of human learning. Ara expected something like the Academy. She expected order. She expected reverence. She expected proper scientific methodology. She found chaos. The laboratories were messy. Equipment lay scattered across benches without any apparent organization system. Graduate students conducted experiments without filing the proper theoretical frameworks first. Some of them did not even seem to have theoretical frameworks at all. They just built things, tested them, and wrote down what happened. How do you know what results to expect? Ara asked one young researcher who was welding pieces of metal together while loud music played from a device in the corner. The researcher pushed up a protective mask and grinned. That's the fun part, we don't. But how do you know if an experiment has succeeded? If it does what we wanted, it succeeded. If it doesn't, we learned something. Either way, we win. Ara documented this conversation in her report. She labeled it as evidence of human scientific immaturity. But something about the young researcher's words stuck in her crystalline memory and refused to leave. The pattern became clearer as the weeks passed. Human scientists did not treat physics as sacred truth. They treated it as a puzzle to be solved, a game to be played, a challenge to be overcome. When an experiment produced unexpected results, they did not check their work and assume they had made an error. They assumed the universe was telling them something new. The most disturbing example came during a doctoral defense that Ara was invited to observe. Doctoral defenses in the Academy were solemn occasions. Students presented proofs of existing theories. They demonstrated their mastery of accepted physics. They showed that they could carry forward the torch of knowledge without dropping it. Human doctoral defenses were different. A young woman named Sarah, apparently related to the engineer, stood before a committee of senior professors. She presented a theory that directly contradicted established understanding of gravitational fields. According to her mathematics, gravity was not a fundamental force at all, but an emergent property of something deeper. Her work suggested that the accepted models of gravitational physics were incomplete. Ara waited for the committee to reject this heresy. Instead, they smiled. "Interesting approach," one professor said. "Your math is a bit rough in Section 3, but the core insight is promising. Have you considered applying this to the dark matter problem?" "I have some preliminary models," Sarah said eagerly. "If I'm right, dark matter might not exist at all. We might be observing gravitational effects from dimensions we can't normally detect." The committee did not expel her. They did not discipline her. They praised her audacity and suggested she continue developing the theory. One professor said something that burned itself into Ara's memory. "The universe doesn't care about our models. Our job is to make better models." Ara spent 3 months embedded in human scientific institutions. She visited laboratories on every continent. She observed experiments in physics, chemistry, biology, and fields she had never heard of. She documented 847 instances of humans attempting things that, according to established physics, should not work. 12 of them worked. The success rate was tiny, pathetic really, but those 12 successes included things that the Academy had declared impossible for thousands of years. The humans had failed 835 times and they had not stopped. They had not given up. They had kept trying, kept pushing, kept daring the universe to prove them wrong. And sometimes the universe had given in. The breakthrough in Aura's understanding came during a late-night conversation with Dr. The human ambassador had returned to Earth briefly to check on her research team. She found Aura in a campus coffee shop, staring at data tablets with growing frustration. "You look troubled," Doctor said, sitting down across from her. "I am trying to understand how your species broke the constant," Aura admitted. "The mathematics are clear. The limit is absolute, and yet your ships exceed it daily." Doctor ordered something called coffee. "Can I ask you a question first? How did your ancestor discover the constant in the first place?" "Through rigorous theoretical work. The elder spent 200 years developing the mathematics. They tested the theory against observed phenomena. It matched perfectly. The constant was proven." "And after that, did anyone try to exceed it?" Aura's crystalline form flickered with confusion. "Why would they? The mathematics proved it was impossible." Doctor smiled gently. "That's the difference, I think. When a human scientist proves something is impossible, other human scientists treat it as a challenge. We have this strange relationship with limits. We don't like them. We want to break them just to see if we can." "But that is inefficient," Aura protested. "Most attempts to exceed proven limits will fail. Resources are wasted. Time is lost." "True, but the ones that succeed change everything." Aura considered this. In the Academy's approach, proven laws were protected and refined. Generations of scientists built upon established foundations without questioning them. Knowledge accumulated slowly but safely. Nothing was wasted on impossible attempts. In the human approach, proven laws were targets. Scientists attacked them constantly, looking for weaknesses, searching for loopholes. Most attacks failed. Resources were wasted. Time was lost. But occasionally, very occasionally, someone found a crack in what everyone thought was solid stone. The Academy had built a cathedral of knowledge over 12,000 years. The humans were constantly setting their cathedral on fire to see what would not burn. "Your approach is dangerous," Aura said finally. "It is," Doctor agreed. "We nearly destroyed ourselves several times. We made weapons that could end our species. We changed our planet's climate by accident. We're not careful, we're not wise, we're just stubborn. And yet you exceeded the constant. And yet we exceeded the constant." Aura's report to the Academy was long and detailed. It described human laboratory practices, educational methods, scientific philosophy, and cultural attitudes toward knowledge. But the core message was simple. The Academy's laws were not wrong. They were incomplete. They described boundaries that no one had thought to push past, because pushing was considered disrespectful to knowledge itself. Humans did not respect knowledge. They respected truth. And they understood that truth sometimes hid behind the walls that knowledge built around itself. The report caused chaos in the Academy Council. Some members demanded that Aura be disciplined for suggesting that proven laws might be incomplete. Others called for the immediate adoption of human scientific methods. Factions formed. Arguments erupted. For the first time in 3,000 years, the Academy was divided. But High Academician read the report 3 times. The being of pure geometric thought considered every word, every observation, every implication. And when the council demanded a response, said something that no High Academician had ever said before. "Perhaps we have been protecting our knowledge when we should have been testing it." The words hung in the air like a challenge, like a door being opened, like the beginning of something that could not be stopped. The Great Revision was about to begin. The Great Revision began with arguments. For 17 cycles, the Academy tore itself apart trying to decide what to do with the uncomfortable truths that Professor Ara had brought back from Earth. Conservative factions insisted that human methods were dangerous and their results were flukes. Progressive factions demanded immediate reforms. And in the middle, the vast majority of academicians simply did not know what to believe anymore. High academicians spent the first 3 cycles listening. The being of pure geometric thought floated through meetings and debates, absorbing every perspective, considering every objection. Some voices called for humans to be quarantined as a reality hazard, banned from interacting with proper galactic civilization until they learned to respect established physics. Others proposed that human discoveries be suppressed entirely, hidden away to preserve scientific stability. Understood these fears. The Academy had spent 12,000 years building a perfect understanding of the universe. Every law had been tested. Every theorem had been proven. The foundations were solid. The cathedral was complete. And then the humans had arrived with their messy mathematics and their stubborn refusal to accept impossibility, and they had shown that the cathedral had holes, that the foundations had cracks, that 12,000 years of perfect certainty had been built on incomplete observations. It was terrifying, felt it personally. Everything the high academician had believed about reality had been shaken. Every assumption had been questioned. The comfortable certainty of proven physics had become uncertain, and uncertainty was uncomfortable in ways that geometric beings were not designed to handle. But was old, 300 years old, and in that time the high academician had learned that discomfort was often the first step toward growth. In the 4th cycle, summoned Doctor back to Nexus Prime. The human had continued her work as ambassador, traveling between Earth and various galactic institutions, trying to smooth over the chaos that her demonstrations had caused. She arrived looking tired but determined. "You asked to see me, High Academician." "I wish to understand something," said. They were alone in the High Academician's private chambers, surrounded by displays showing the ongoing debates in the Council. "Your people break laws of physics. You push past proven limits, but you do not do this randomly. There is a method, a philosophy. I wish to understand it." Doctor sat down on a bench designed for biological visitors. She was quiet for a moment, collecting her thoughts. "It's hard to explain," she said finally. "It's not really taught. It's more like a cultural attitude. We've always been uncomfortable with being told we can't do something, even when the mathematics prove it. Especially then," she smiled slightly. "We have a saying, nature to be commanded must be obeyed. One of our early scientists wrote it. It means that if you want to do the impossible, you have to understand why it's considered impossible first. You have to learn the rules deeply enough to find the exceptions. Consider this. So you do not reject physics. You study it specifically to find its weaknesses." Exactly. Every law describes what happens under specific conditions. We look for conditions that weren't considered. We ask questions like, "This law was proven using certain observations. What if we observe from a different angle? What if we change the scale? What if we add energy in unexpected ways?" And most of your attempts fail. Most of them fail spectacularly. We have a lot of stories about experiments that went wrong. We blow things up. We create messes. We waste resources, but we learn from every failure. And sometimes, maybe one time in 100, we find something new. Was quiet for a long time. The geometric folds of the high academician's form shifted slowly, processing information, reconsidering ancient assumptions. Finally, spoke again. "The Academy has always treated failure as shameful. A failed experiment means the scientist made an error, made a mistake, did something wrong. We treat failure as data," Doctor said. "Maybe the most valuable kind, because a failure tells you something unexpected about reality. It tells you that your model doesn't match what's actually happening, That's precious information. That's a gift from the universe. A gift, tasted the word. It did not translate perfectly into geometric thought, but the meaning was clear. You see the universe as a teacher, not as a set of laws to be obeyed, but as a puzzle to be solved, a conversation to be had. Yes, Doctor leaned forward, her eyes bright. The universe doesn't give up its secrets easily, but it does give them up. You just have to keep asking questions, keep pushing, keep being willing to be wrong. The conversation lasted for several more hours. By the end, understood something that changed everything. The Academy had been treating physics as religion. Laws were sacred. Theorems were holy texts. To question them was blasphemy. But humans treated physics as science in the truest sense. An ongoing investigation, never complete, always open to revision. Both approaches had value. The Academy's careful accumulation of knowledge had built the foundation of galactic civilization. But somewhere along the way, accumulation had become preservation, and preservation had become stagnation. No one had tried to break the laws because everyone believed the laws could not be broken. The humans had shown otherwise. In the fifth cycle, proposed the new charter to the Academy Council. It was radical, it was uncomfortable, it changed everything. First, the principle of perpetual questioning. No physical law would ever again be declared absolute. Every theorem would carry an expiration date. Every proven limit would be regularly challenged. Not because the laws were wrong, but because treating them as eternal truths prevented the discovery of deeper truths. Second, the tolerance of failure. Failed experiments would no longer be treated as shameful. Scientists who attempted impossible things and failed would be praised for their courage. Resources would be allocated specifically for high-risk investigations with low probability of success. Third and most radical, the Office of Impossible Attempts. A new department would be created, staffed jointly by humans and galactic scientists, whose sole purpose was to try things that could not work. They would attack proven limits. They would question established laws. They would embrace failure as a tool for discovery. The conservative factions were horrified. "You are asking us to tear down 12,000 years of certainty," one ancient academician protested. "You want us to become like the humans, chaotic, undisciplined, dangerous." "I am asking us to remember what science actually is," responded. "It is not the accumulation of facts. It is the search for truth. And truth does not care about our comfort. Truth does not care about our certainty. Truth simply is, waiting to be found by those brave enough to look." The debate raged for another 12 cycles. Factions split and reformed. Ancient alliances crumbled. New partnerships formed between species that had never worked together before. And slowly, painfully, the Academy began to change. The Office of Impossible Attempts opened in the 17th cycle. Its first team included Professor Ara, who had been forever changed by her time on Earth. It included the engineer who had sketched impossible equations on a napkin. It included representatives from 30 different species, all united by a willingness to be wrong in pursuit of being right. Within 5 cycles, the office had broken 37 additional laws. Warp travel efficiency doubled when they discovered that the speed limits were not limits at all, but thresholds that opened into new forms of transit. Synthetic gravity became possible in portable devices when they found that gravitational fields could be woven like fabric under the right conditions. A particularly enthusiastic human team accidentally discovered how to make matter phase through time itself, though they still were not entirely sure how it worked. Each breakthrough sent shockwaves through galactic civilization. Industries were transformed. Technologies that had been considered science fiction became everyday reality. And with each impossible thing that became possible, more scientists joined the office. More species sent their boldest minds to push against the boundaries of the known. The Academy's 12,000th anniversary celebration was unlike any that had come before. The crystalline towers glowed with light from experiments in progress. The grounds hummed with the energy of questions being asked. And in the grand hall where humans had first demonstrated the impossible, Doctor stood at the podium. She had been elected the first human high academician. The vote had not been close. Even the conservative factions had eventually admitted that she represented something the Academy desperately needed: the courage to be uncertain. "When we first came to this place," she said, "we thought we were the students. We thought we had come to learn from ancient masters who understood things we could barely imagine. And in many ways that was true. The Academy's knowledge is vast. Its discoveries are profound. Its contributions to galactic civilization are beyond measure." She paused, looking out at the assembled beings from 800 species. Some were geometric shapes folding through multiple dimensions. Some were clouds of sentient gas. Some were crystalline structures or biological organisms or forms of matter that had no name in any human language. All of them were listening. "But we also brought something," she continued. "Not superior knowledge, not better technology, just a different attitude, a willingness to be wrong, a stubbornness about limits, a strange belief that the universe has not finished revealing itself and never will." The new motto of the Academy glowed behind her, carved in quantum-stable crystal that would last for millions of years. "What else don't we know?" "The universe has no laws," she said. "It has secrets, and secrets are meant to be found." In the audience, watched the small human speak. The high academician had seen much in 300 years, but nothing had prepared for this moment. Standing in the grand hall of the institution, they had served their entire life, listening to a species that had arrived as infants and become teachers, and feeling something that geometric beings rarely felt: hope. The universe was larger than the Academy had imagined. Reality was stranger than any theorem could capture. And somewhere out there, beyond the boundaries of known physics, more secrets waited to be discovered. All they had to do was keep asking questions. All they had to do was keep being willing to be wrong. And that, the humans had shown them, was the easiest thing in the world. You just had to remember that truth was more important than comfort, and discovery was more important than certainty, and the joy of finding out was worth any number of failures along the way. The celebration continued long into the night. Scientists from across the galaxy shared their latest impossible attempts. Some had failed, some had succeeded, all had learned something new. And in the office of impossible attempts, the lights never went out. Teams worked through the celebration, pushing against limits, questioning proven laws, embracing the beautiful uncertainty of a universe that refused to be fully understood. The humans had broken physics, and in doing so they had set it free.